So today in this video we are going to take a look at a power meter using Arduino. So let's start, right? Arduino has 10-bit ADC, so that means we could use the 10-bit ADC to our advantage. And yeah, so this is a code for that. So let's try first of all making a circuit diagram. So for that I'll be drawing right now. Uh, okay, so opening the program. Right. So this is a circuit diagram. I will draw a circuit diagram right now. This is four resistors in parallel. Your circuit may be different. Like it does not have to be same as mine. And here is VCC, and here is ground. And one more thing is here I have to have a pro point, so let's call it something like yellow, and this is a pro point red, and this is a pro point black. So these are all there is, and yellow will go to the A1, and red will go to the A0, and we will go to the ground. So this is a circuit diagram. This is a simplified circuit diagram for our little experiment around here. Right. So let's minimize that and let's look at the code. Right. So one thing you could see is this code is like small, really small. Because I am offloading all the processing to the Python. So you kind of now know that if you don't have Python, then yeah, like you should have Python, and for this code to work you should have Python. It doesn't mean that Arduino can't log by itself. You could in theory use a SD card module and log to that directly, but I do want to log it accurately and those kind of things. But yeah, it is totally possible with the SD card module, right? So here you can see these lines, right? So these lines are basically for calculating the VCC using the 1.1 volt reference, which is internal to the AVR microcontrollers. So what we are doing is we are taking 1.1 volt and calculating what the VCC is. So for those people who don't know what is VCC, VCC is the power which is applied to a IC or anything. So yeah, it is like the power rail, the main power rail. So here for the Atmega we are having the 5 volt power rail, and that power rail is directly connected to the laptop or PC, whichever you are using, right? Most of the times this is not a especially 100% bang on power rail. It will be like 10% off. Maybe like I have even seen cases where there was like 4.5 volt at the power rail. So anyway, you kind of know the thing, right? Normal equation for this is you normally get the ADC reading and you divide it by 1024 because you do have 1024 steps into the VCC. That will be the voltage. Okay, so what we are getting is we are getting the voltage in millivolts. So yeah, we will be getting the answer in millivolts also, right? So first of all, begin. I'm just using a really crazy bow rate, why not? You don't need to use that, I guess. Long VCC is equal to read VCC. So now you are getting the VCC. It is a long data type, so it could in theory store more than integer. And A0 is an analog value, and we are storing it to small a0, and It is also long because you will know that we are going to multiply with VCC, which will give us a longer value. So anyway, A0 multiplied by VCC divided by 1024, just so that I don't want to get start converting into float, right? So the multiplication goes first. Anyway, that is that, and A1 is the other one. So A0 was a VC, like it's the voltage of the battery, right? And A1 is a current measurement. Actually, how it became a current measurement is that you can kind of see that. Oh my God, it is now mentioned, right? This is 100 ohms. These all are 100 ohms. 100 ohms. So this is 1 ohm, and this is our 100 ohms. So voltage drop across this will be equal to the current. So we can say V is equal to IR, right? Where R is equal to 1, then we can say V is equal to, we can say safely that V is equal to I. So that is what we are doing, right? Here you will get positive voltage more than this, so you kind of have to subtract whatever you're getting from the VCC to this. So yeah, you will get that. Otherwise, what you can do is you can connect the ground here and VCC here, both works. Yeah, anyway, this is a code. So yeah, we are getting the A1, and A1 basically the same deal is happening, just doing the calculations in millivolts, and after that I am just printing it. So kind of you can see current, then the current value, and there's the tab space, then voltage, then the voltage value, and um, there is no tab space. It is a print line. So yeah, there was no print line here. Anyway, you can see I have set a delay of 100 so that it doesn't overwhelm my PC with data, because storing data is also really hard. Like if you want to log it for like 2 3 or maybe 11 or 12 hours, it is like it will take 4 or 6 GBs of data. So yeah, we want to do that, right? Okay, so let's go into the Python code. So yes, trying to get the Python code. Yes, so here you can see that this is a file open command, and right. So this is the first thing we have drawn. So this line is for importing serial. So yeah, you know what is meant for. Import datetime and serial, like this is initializing the serial. For me, TTY-ACM2 is serial port. Sometimes you may have to chmod on this for that, or otherwise run your program as root, right? Anyway, those aside, you can see the baud rate here, and the timeout for the read functions. Now equal to datetime dot now. So what we are really doing is we are getting the datetime. Yeah, and logging the time right now. And we are opening a file called log.csv in my RAID, and after that we are writing current voltage. There's a space so that we know that these two are different and different cells. If you're opening LibreOffice, it will ask which is a delimiter. So yeah, right. And we do have this loop where just read lines, strips, and does all the things with that. It actually finds the correct information from the bit from the Arduino. So yeah, what it basically does is current is to the thing, right? So it will find these two first is to, then after that it will take that and compute the integer. So sometimes I get a problem where it is not saying the whole thing. So yeah, if there is some error, then handle the error, and if you did keyword interrupt, then that. And finally, even if it is interrupted or not interrupted, you have to close the file and close the serial. Yeah, it is not mandatory, but yeah, it is cool to do that. Right. So you have this log file, and we are going to compute the mAh milliamp hour capacity of the battery. So data equal to your dot read, data equal to data split. So we are splitting by slash n. So each line, right? And this is for like I may take 1.1 seconds to basically plug in the battery. So ignoring those kind of results. And there was some more data which was zero, so yeah, I did that also. uh, okay, so now we are having interesting things, right? Okay, let me go to the obvious. Yeah, right. If past equal to none, so yeah, past equal to none, that is there is no past, and write a past and append to the list. And yeah, otherwise, if the past is not done, then update the past and write it to the list, right? So the thing is, we are trying to get a second, like 1 second, one sample, second, one sample, like that. Each second we get one sample. Now we have many samples, and we are getting like we are trying to get only one sample. So we are remembering the last second and this second, like if they are different, then do the operation, right? Anyway, a equal to 0 and 4 in range of. So this is basically to split and save the all the values. So yeah, and we have this. So S is a sum variable, and we do have the sum variable as 0, and we are trying to take the sum of all the powers. So yeah, we want everything in watt hours, but now we are going to compute in watt seconds. Voltage and current will give you watt, and if you want it in hour, then uh, you have to multiply by the hour, right? So yeah, that is that, and we do have it in watt seconds. So divide by 60, divide by 60, and we do have millivolts multiplied by millivolts. So to get it back in the original shape, we have to divide it twice by 1,000. And after that, just use the normal things like amp hour is equal to watt hour divided by voltage, and that is done here. And amp hour start 1,000, so that will basically make it millivolts again, milliamps again, and yeah, and the watt hour is displayed in amp hour. So yeah, this is a whole program. So if you like this kind of video, just give this a thumbs up. If you have some questions, so if you have some suggestions, just leave in the comments below. And uh, yeah, stay tuned and see you guys in the next video. Bye bye.